I went through and tested all the tubes and found 4 weak tubes, 2 in the tuner and 2 in the IF. So those will get replaced. Haven't checked the I tube yet because my Hickok Cardmatic does not have a card for it. However, the owner of this set did actually proactively buy a full set of new tubes, including a 6AL7 I tube. So all the tubes can be replaced, no problem. Then I went through and checked some of the power resistors and the focus control, and bingo, the focus control is bad. This is a big power rheostat here, 1200 ohm, rated for 25 watts, and I found the break right about where that scratch mark is. Don't actually see it. Could very well be down inside here, where it's been potted up in a ceramic compound. Well, this is a common issue with these Dumonts, and I've already tracked down a replacement and it's on the way. So that explains what I was seeing with that substitute focus coil resistor. And here is where that focus coil actually connects. So in an earlier installment I talked about this power supply being an odd design in that all the power for the set goes through this focus control. Well, that isn't quite true. What I was neglecting to do was to put that focus control in place. So when you look at the schematic like this, you think, oh, all the power is going through the focus control and then down to the bleeder resistors. Well, no, that focus control via the socket actually is another path for power to go through. So all the power goes through the parallel combination of this power resistor and the focus coil, and the focus control kind of sets the ratio of how much power goes through one side versus the other. So imagine there's a break in this. Well, when you set that center control, that center wiper there to one side, all the power is going to go through this resistor and none through here, and it's going to be cold, which is what I first experienced. Later I tweaked it and the set was performing better. Well, that's when I went to this side, and then all the power was going through this resistor and it was getting really, really hot. No power was going through here. Regardless, either side, not enough power is going to be going through to this, and I was measuring about 170 volts here rather than 200. So a parallel combination of these two is going to be much lower than either one of them on their own. It's going to be in the ballpark of around 600 ohms, I would guesstimate, maybe a little less. So in the meantime, yeah, I could pop the control off of this set, but I'd rather not, because I don't actually need the control, because I don't. I'm using this test CRT, which is autofocusing, doesn't need this focus coil. That's why I'm using this power resistor. But what I can do is stick up a couple 600 ohm power resistors and put them in series and connect the center to here and either side to these two guys, and replace the missing tubes and power the set up again. Something else I started doing was cleaning it. While I had the tubes out, I sprayed some cleaner on here and wiped it down, and this set must have been in the home of a heavy smoker, as this chassis was quite discolored, but turns out the tar and nicotine do a great job of preserving chassis. So I presume this is cadmium plated, as most are, and there's no corrosion on it, that usual greenish, whitish cadmium oxide and cadmium sulfide corrosion. And these caps came out especially nice. So I've tried a few things. I've tried some CRC contact cleaner, works pretty nicely. Also tried some Spray 9, which also works pretty well. Basically just spray it on, work a small area at a time, let it sit for a while, and then wipe it off. Gradually the crud comes off. Probably done one pass over most of this. Alright, so I'll set the cleaning aside for now, populate the bad tubes, replace the bad tubes, and rig up a replacement substitute for this guy, and give this another go. Here's a closer look at that 6AL7I tube. The old one is the Foco on the left, and the new one is the GE on the right. And then you can see, looking at the targets, how much use the one on the left has seen with all the discolored phosphor coating there. So I don't know that the problem is simply that it's worn out, but certainly this one looks fresher. There are numerous resistors going to it that I'll get around to checking, but I suspect just putting in a better tube there will help out here. It is here, and I know in the older radios there was notoriously a 1 meg resistor inside the socket that would drift up high and cause it to not work well. I don't know if that's the case in this, or if it's somewhere down in the chassis. Here's how I rigged up the temporary replacement. I put the control back in and wired up the 2 outer legs, substituted 2 power resistors, connected them together, and that's where the center tap is going. Now I should add that there are actually 2 paper caps I haven't replaced yet because they're just kind of buried down in there, and I've got lots of resistors to check, and there are some modifications I want to make. In particular, there is no cathode bypass cap on the audio output tube. This guy right here, see how they show 10 microfarad cap there? Or the earlier versions, which is this, doesn't have that. And it's recommended that you add one to boost the gain, so I will be doing that as well. Well, things are better in some regard. For one, the I-tube is certainly working now. It's lit up nice and bright, and it's doing its thing, which isn't a whole lot really. Basically, when you tune in a station, the one on the left gets really long. That's about all it does. But unfortunately, the sync is still really unstable. However, the horizontal oscillator is not freaking out like it was before. And it's nice and bright, and you get contrast, just very, very, very unstable. And still no sound. So, more work to do for sure, but progress. So, first thing I'll do is get rid of those 2 paper caps, and I'm going to double check things in the sync circuitry. Alright, I replaced those last 2 caps and added the 10 microfarad cathode bypass cap in the audio output tube, and managed to get this set on its side so I can poke around with things. And in particular, I've been looking at the horizontal circuit. So, for example, this is a key waveform, the Synchroglide AFC circuit, and that is perfect. These 2 peaks should be equal height, and it looks exactly like it's supposed to, and is the right height. So I'm working my way back, and when I look at this point down in here, things are a little ugly. They include some waveforms on the schematic, which is convenient. So that is this point, pin 1 on a horizontal saw generator. It should look like that, which it sort of does, except for all the crazy noise on there. And that noise, I'm pretty sure, is what's causing this mess. So where is it coming from? Well, I'm going to work my way back. I'm thinking it's somewhere in here. What this sync circuitry is supposed to do is filter out the sync pulses from the video signal and amplify the signal a lot and clip it off. So regardless of the input signal level, you should get the consistent, clean sync pulses out of it. So how about I take a look at this point here, pin 1 on the 6A6, and see what that looks like. Well, it's kind of a mess. I mean, there's the sync pulse, but we're getting a lot of video coming in there too. And it looks like it's the opposite of polarity of what it's supposed to be. Finally, I think I may have found the problem. The last mica cap I tested in the sync circuit seems to be faulty. Now, the sync circuit I've been showing you from the Dumont info doesn't quite match. This set is a little newer than the one published there, but not as new as the one covered in Sam's. Well, I dug into 1952 Beatman's Most Often Needed, and this pretty much matches. So the cap I'm testing right now is this 33 microfarad off of pin 5, otherwise known as 33 picofarad. And we do have leakage. Not a lot, but mica cap should have no leakage whatsoever, that's for sure. And when I go to check for capacitance, nothing. No eye deflection whatsoever. For comparison, I'll pull out a good 33 picofarad mica cap and show you how it should test. Luckily, I happen to have one on hand. Let me check this guy. Very distinct eye opening. Whereas the other cap, we got absolutely nothing. And as for leakage, no leakage whatsoever. Alright, so I'll clean up the mess I made of things in here. I still have to reattach the other mica caps. And those resistors, they were close, but they've drifted a little bit, so I might as well replace those while I'm down in here. And of course, replace this guy. I replaced that leaky 33 picofarad cap, and the sync got a little better, but it still wasn't that good, so I started checking the rest of the mica caps, and one after another were bad. Now, not all of these are bad, but most of them. And in particular, this guy, this 270 picofarad going to this coil here, which is combination horizontal oscillator coil and a part of the automatic frequency locking circuitry was bad. And I replaced this cap, got a solid sync. I then went and checked the caps in the audio amp, audio IF, and output stage, and when I replaced these two guys, I finally got some sound. It's not great, but I think I need to go through and do an alignment. Alright, so with the set now working fairly well, I decided to deal with one annoying issue, which was the tuner. As I tuned around, would tune around the dial, I was getting a lot of dropout. And I'm pretty sure it's because it was dirty. So I unmounted it and cleaned it up. Cleaned out all the old grease and got some deoxit on there. And got some Lubriplate 105 on the bearings. It's kind of cool to look at the original service info, and this is what they recommend using, and it's still made, so that's what I used. Really nice, light grease there, so this is all moving very nicely now. So that needs to get reinstalled. But while it's out, I want to work in this area, with that out of the way. It's more opened up, and what I want to do is replace these power resistors. This is the third one of these chassis I worked on, and in the other two, some of these resistors had failed, so I figure eventually these are going to fail as well. Plus, I already ordered up the replacements, so just like on the other chassis, I'm going to be using these chassis mount power resistors, so I need to get my drill going and drill out the rivets and mount the new placements down here. Actually, there's one final thing, which is the burned out focus coil. Well, luckily, there's a readily available vintage replacement from surplus sales in Nebraska. Not exactly the same. The original was 1200 ohms, and this is 1000 ohms. So what I'm going to do is tack a 100 ohm resistor onto either end to make up the difference. Although I think 1000 ohms is probably close enough that it would work as is. So what I needed to figure out is what wattage 100 ohm resistors do I need? Well, here's the circuit. So there's focus control, and it goes to these two resistors. So where it says going to J204 pin 4, that's going to this resistor. So pretend that's not even there. So here's the circuit. And we've got a couple voltages to work with. We got 200 on that side, and we got 305 going to the center wiper. So how do we figure out how much wattage is being dissipated by that focus control? Well, I figure the simplest way to do it is just assume that the wiper is all the way at the top. Then we know we got 300 volts going through 1200 ohms, going through about 800 ohms, and then about 200 volts over here. So about 100 volts across 2000 ohms. If we do the math, that turns out to be 50 milliamps of current. And power is current squared times resistance. And if you do that math, 50 milliamps squared times 1200 ohms, you get 3 watts. That's right. This big 25 watt control actually has 3 watts of power being dissipated in it. So why would they use a control this big? Well, one, it doesn't hurt to go big. You generally want to go at least twice the wattage to give yourself some overhead so that things don't burn out. So, but a 10 watt probably would have been just fine. But the other issue is these probably weren't custom ordered, and they had to go to their parts supplier and see what was available. And they might have also wanted to buy these in bulk for some of their other models. And then to this day, these still make these controls, and they typically come in 10, 25, and 50 watt sizes. So you can't, just unless you really want to spend the money and have them custom made, you got to pick from what's available. So I'm going to get this in there, but I have to do a little bit of work first. The shaft is slightly too long, so I need to cut off about 1/4 of an inch. I'll mark on there, and I need to grind it down a little to make it sort of a half moon shape for the knob. So very lucky that this is available and not too expensive. It's $8 from surplus sales in Nebraska. Because if you go to somewhere like Mauser Electronics, these are more like $35 each. And also very lucky that the shaft is suitable. It's quite often modern controls, the shafts are not as long, and quite often they're plastic. But this is a nice solid metal shaft. So I'm going to get my Dremel tool going and cut this down, and I'm going to drill out the rivets on these power resistors and replace those and get everything back together and fire it up and show you how it plays. Alright, so here it is all back together. I'll flip it down and do a final power up test. Show you guys how it's working. Here's that cut down shaft. And the lubed up, cleaned out tuner. It's running very nicely now. Alright, I got everything rigged up for one last power up test. I'll get the other chassis back up on the workbench to finish off that tuner. Nice strong sound, clear picture. Not the easiest sets to work on, but once you get them all set up, they do work quite well.
That's why I turn it low. It don't concern you.
And if I tune around over past TE band, FM radio reception. Now I don't have an antenna hooked up, it's just going through my feed to my converter box, but even so, once you pick up a few stations. So, although it was quite a hassle to get the tuner out and clean it all up and then reattach it, definitely made a big difference. Tune's a lot smoother now. Let me get back over to TV reception.
Gentle cleansers. Good. Why do you tell?
Got the yoke horizontal windings backwards. That's why the print is backwards.
Other sour creams. Only simple ingredients, and it's 100% pure.
Alright, so get the other one up here and hope it turns out as nicely.
Thanks for giving Leanne the strength to outrun her brother. Thanks for giving Victor the energy to be the rowdiest fan.